My name's Eric Thone. I'll be talking to you about a lot of our cloud use cases. We'll cover a couple background slides just in terms of context, pretty high level, you'll all be familiar with that. Talk about some of the use cases that we've seen from some of our customers that we have in deployment today. And then Don's going to take you in a little bit deeper into some of the technical aspects of it and show a demo for you. So to kind of baseline that cloud evolution, things were on site. People started to add private cloud, and we still have many customers that look this way today, whether that be hub and spoke across many different edge branches going into a central site. But more and more of our customers have started to, of course, adopt Saas applications. You know, some people will call this cloud, some people won't, depending on what you think about it. Hybrid cloud, we see many of our customers starting to do this now, often supplementing what they have in a private data center with something inside the public cloud in some fashion. And then even more so today, multi-cloud. More and more of our customers are becoming interested in understanding or future-proofing the sort of way that they're designing their networks to be able to accommodate multi-cloud in the long term. But this is sort of our taxonomy in terms of the way we think about things and what we've seen in terms of evolution as well. Just to reinforce some of those trends, you know, this is one survey, but many say things similar to it, where when you look at the percentage of what especially large enterprises are deploying, you see a lot of hybrid cloud today, and that's starting to shift more into the public cloud. In some of these right scale surveys, they start to say, hey, what's coming up? And more people are starting to accept that public cloud will happen. And you know, when we talk to customers, there's different reasons for this. It depends on the individual customer. You know, supplier competition, it's good to have multiple sources, of course. Diversity, really for reliability. Maybe it's security that you're worried about if one of the big clouds goes down and you have a lot of your services there, that's a problem. And sometimes it's for features and performance. You know, in some cases, it might be that Amazon has some feature sets that are better for certain SaaS applications than, say, Azure. It just depends. It varies based on them. But one of the things that I think we see, especially when you talk about large enterprises, they have multiple lines of business, and individual lines of business might choose a different cloud for a different purpose. And so the IT person is sort of stuck in between, and they're going to have to deal with that. So in our minds, it becomes sort of an inevitable conclusion that you're going to have a lot of different clouds, a lot of different infrastructure out there, and you want to have a networking solution that can accommodate that. So when you think about challenges, so what is the problem if you start going to the cloud? And this is, again, it's just one survey. It's just trying to capture the general sentiment. And one of the big ones, of course, is security. And you know, this calls it out as security, compliance, privacy, et cetera. And I think you've talked through a lot of the security use cases already earlier today. Whether that's a data breach, you know, you stick something in the cloud, now people start taking stuff out of it, or whether it's unauthorized access, someone being able to access something within the public cloud that perhaps they had better controls on was in the private cloud. Perhaps they're starting to use something different in the public cloud and it's difficult to keep track of. So security is often a large talking point when you talk about these cloud deployments. And that's a benefit for us, and we'll talk about the advantages we have there. In the other category, one of the things that becomes very challenging for the multi-cloud experience especially is proprietary tools. So you might have your own Cisco routers down here at your own branches. But when you start to think about what you do in AWS, are you going to deploy another Cisco router there? Are you going to use their transit gateway? Well, if it's a transit gateway, then they have their own set of tools, their own way to configure it. Now you throw Azure into the mix, it's yet another way to do something. So now, as an IT professional, you're dealing with a lot of different tools. It's really heterogeneous complexity. So each of these different places, each of these different deployment scenarios might have a different tool, a different API, something else to work with. That adds a lot of complexity. You also worry about vendor lock-in. If they're really complex and proprietary, do you put everything in AWS? Are you stuck in AWS after that? And then, of course, the lack of visibility. If you start to think about, I have different tools, different products in each of these places, I have to go to each of those products to try and diagnose something that's going on, to try and figure out what's happening there. So there's a number of challenges that sort of present themselves, whether you're talking about going to one public cloud or you're starting to talk about multi-cloud. And we think they'll only get worse as time goes on. So when we think about our solution, how that relates to this sort of context. And this is, again, sort of reviewing many of the features that we already talked about, but sort of in this cloud context to just set the stage for why we think they're relevant. One thing is software-based and homogeneous is very important, right? If you're talking about virtualizing everything everywhere, having a software-based solution for your networking makes a lot of sense. You're already thinking in terms of that. Homogeneous actually becomes very powerful. Even if it might be, let's say, cheaper to use tools that are in Amazon, if you start to do Amazon and Azure and their different tools, and you have to train your people to do that, that becomes more complicated. So it's good to have a homogeneous solution across this. When we think about the conductor-based solution, our management solution, single pane of glass, that then becomes something where from a single pane you can see what's happening in AWS, you can see what's happening in Azure, you can see what's happening on the branch. That's a very positive thing. It makes everything simple for you. High performance, they spent a lot of time, I think Ritesh talked a lot about the advantages of being tunnel-free. This definitely applies when you're talking about the cloud, whether it's going into the cloud or in many cases, I think one of you mentioned to me last night, going out of the cloud, right? Because you're going to probably pay more getting stuff out of the cloud than putting it in. They all want you to send your data into the cloud. It's when you want to leave from AWS to Azure that you have a problem you have to worry about. That's where something like overhead might make a difference for you, for example. Or similarly, we've encountered a number of cases where people are suffering from performance penalties when they're trying to go from a public cloud, an Equinix hosting site, into AWS, for instance, or into Azure. It's not always as simple as you might think it is. So high performance matters a lot there. Security, those global access policies that I think Lane was showing you how you can visualize them, how you can set them globally. And again, this is that homogeneous idea that I can set access policies that apply in AWS, that apply in Azure, that apply in my branches. It's all consistent. If you're using different proprietary platforms in each of those places, that's complexity that you have to worry about. So each of them have their own tools, and they're quite good. If you had everything inside AWS, they have a great suite of tools to do everything. It's as soon as you add stuff somewhere else that now you're the one that's stuck with the responsibility to make sure my policies in Azure are consistent with AWS. AWS is not going to give you a good set of tools to go over to Azure to configure Azure properly, right? They don't have the right incentives to do that. It really suggests third party in those particular cases. Directionality, I think Prashant and Lane probably covered a lot of this in terms of the idea of being directional in these particular situations is very powerful. If you're putting a bunch of data in one of these sites, you want to make sure that it doesn't get out. You don't want to leak that data. You don't want people to access that data. So having a secure network framework becomes very important. Finally, reliability is sort of an obvious one. If I used to have an application that was local to my users and I suddenly put it in the cloud, if you lose connectivity to the cloud, your users can't do anything. I mean, it's just obvious, but like reliability is actually very important in this particular use case. When you stick stuff in the cloud, it needs to be very reliable. So to some degree, I think many of these advantages that we have in our product are sort of like apple pie. I mean, of course your product should be secure. Of course it should be software. Of course it should be reliable. But I think as we've discussed, there's many unique ways in which we do that because the underlying architecture that we're implementing these advantages in is a very unique approach to it. But these are the advantages that we see. So I wanted to take you through a couple different case studies of where we have existing customers that are deploying us, especially in these cloud scenarios. And to some degree, I don't want to suggest that cloud is completely different than everything else we were talking about so far today. Oftentimes, in many of these scenarios, there's a bunch of stuff outside the cloud, branches, going into the cloud, a hub and I mean, it's not too different. It happens to be because you're sitting inside the cloud that we often talk about these cases. But I'll give you a flavor for what's sort of unique about them from a cloud perspective. The first one is a manufacturing company that has many different factory sites. They tend to aggregate data into their private data centers, and then they want to get some of that data into the public cloud, in AWS in this particular case. The challenges that they were running into, and one of the reasons that they came to us, is that they were not getting high performance going from their private data center into the public cloud. In this particular case, they would have direct connections. So this might be at Equinix or another place where they can peer into AWS and then getting into AWS. In some cases, they were going between regions. So they're a global company. They have sites all over the place. And so in many cases, they want to either have high bandwidth between different regions, or more importantly, and the challenge that they had primarily was getting high bandwidth going direct to connect in here. The two important factors for them were end-to-end encryption. So they needed to have a solution that could encrypt everywhere, and that was important across the way. And so all of these connections they could encrypt, they could control that and do everything there. The second point was high performance, and this is really what prompted them to contact us to begin with, is that they were using an existing Cisco solution, an IPsec-based solution, and the performance that they were getting across very high bandwidth direct connect connections was very poor. They started to test us, and we did a variety of different tests, both and Don will go through some of the test results that we have in a little bit. But what they found was we get much higher performance because we had this non-tunneled solution, okay? And that was very important to them at all their different sites. And so now we're in the process of trying to figure out where should we deploy first, where are the first places to go. But this is a case where that secure vector routing, the tunnelless approach, was very beneficial. So that's a manufacturing use case. The next use case is what I'm calling analytics SaaS. We actually have a couple different companies that are doing this. It's a very interesting use case. You'd say SaaS, isn't that over the top? What does that have to do with setting up a bunch of branch routers? This is an interesting case. What these SaaS providers are doing is they do a bunch of analytics in the cloud, but they're doing analytics on a bunch of voice information from various customers. So down below you have a variety of different call centers. Lots of calls going into these places. And there's a number of new emerging companies that basically take that audio data and process it with AI to determine either security, is it the person who they say they are, or to determine sentiment for different providers. So each of these different companies, as you go across the bottom here, is a customer of this SaaS provider. The SaaS provider is our customer in this case. So you might have a customer A, a customer B, and a customer C. And then these customers need to get their data up into the SaaS provider. So the edge is down here on the customer site, and the SaaS provider is in the core. Originally, in many cases, what they were doing from the edge to get to the SaaS was provisioning an IPsec tunnel from existing on-site gear. Okay? The challenge that the SaaS provider faced in those cases was every customer they went to had a different set of gear. So customer A might have Fortinet, and they call up the SaaS provider and say, oh, can you help me configure my Fortinet to do the tunnel? Then customer B calls up and says, oh, I have this version of Cisco. So now the SaaS provider is stuck figuring out how to configure the Cisco router to terminate the IPsec tunnel up in AWS. So that was one problem they had. A second problem that they had was that even when they configured it as a SaaS service, in many cases, for some reason the service doesn't work. They call up the SaaS provider and say, hey, your service doesn't work. The problem's actually in the network. So not having visibility on the edge wound up being a very important factor to them. So the type of solution that we started looking at and delivering to them was to be able to deploy 128 out at these endpoints. When you start to look at the different customers, they have multiple customers. They might even be in competition with each other. This is a case where segmentation was very important. So the SaaS provider has a variety of different servers or instances up in AWS, EC2 instances in this particular case, but they're essentially on a per customer basis. So customer A needs to only have access to the data that is associated with their service, customer A. They have to segment both within a particular VPC, so EC2 instances within that VPC, but then maybe across regions as well, depending on where both their customer is located and where it's most efficient to be able to do their processing. So segmentation is important. Visibility. This is the one where they give the SaaS company a call because the SaaS service isn't working when in fact it's the network. So in this particular case, for most of these deployments, they actually sit behind another router here. So it's not an SD-WAN use case. It's not using multipath routing from the edge point. It's actually another box sitting further behind a router on site. But the fact that it gave visibility was actually more important than the idea of multipath reliability, at least in the initial deployments. Elasticity, and I think Don was going to maybe talk about this a little bit and plans to talk about it more. So as their customers ramp up in terms of the amount of analytics that they want to perform, the number of calls that might be going in, the number of audio channels that they want to look at, they had to have a way to be able to add additional services, and from customer C, they have to know how to get there, where they're at, and be able to load balance between them, for instance. So elasticity and then understanding where those services are provisioned. And then eventually, an upsell in many of these cases winds up being enhanced reliability. This is more complicated for the SaaS service to provide because you have to have connectivity to the individual paths that might be available, but it was actually less important to them. In this case, and we have some other customers that are doing this, where they're traditionally a SaaS, but if they want to offer a higher SLA, you can add SD-WAN on top of it to be able to allow a higher SLA for your service to that end customer. Essentially, for many of these over-the-top companies, what it comes down to is you just say, we will deliver so long as you get your data to the cloud. Some companies don't want to hear that. They want to, they're happy to pay a provider more if they can provide a higher level of availability. So this is an interesting study where it's a SaaS service. It's desirable for them to put something on-premises to be able to connect to their cloud to deliver better services. And it's, in my mind, it's sort of an interesting use case because traditionally I think of SaaS as over the top, but we've actually had several customers start to do this with us. Any questions on this one? Okay, I'll keep going. Oh, and just in terms of demonstration, I think Don will give you a sense of what you can do for both visibility and then how you would provision some elastic services within our solution. The next case study is an IoT data delivery case study. This is an interesting one because it winds up being multi-cloud. This is a large oil field services company, and they have well sites. So well sites are in the middle of nowhere. No one, you drive out to them. There's no fiber drop. There's nothing like that. And so the well site has connectivity that is almost always at least satellite and sometimes LTE. And so with this provider, you need to just be cognizant of you can be all over the world. And in fact, they've called us about locations we've never even heard of. The way their network is structured is you go across this satellite or LTE service to get to, it's a private LTE or private satellite service to get to their private cloud. It's sort of a point where they will terminate a teleport, where they'll terminate that private network. But then for a particular customer, you need to send data back to that end customer's private cloud, but the service provider also has their own public cloud solution as well. So it's an interesting case where as a service provider, our customer is the service provider, they naturally fall into a multi-cloud scenario because their customers pick some other cloud, right? So I pick one cloud, I pick Azure as the service provider, my customer winds up picking a public cloud here. In this particular case, it's also interesting because what they're doing is they're also provisioning services in essentially an IoT gateway here. So we're co-resident on a platform that has a variety of other local services. In this particular case, they use the Azure IoT Edge platform, and they run different services, IoT applications at the edge, along with us to go back to the various public clouds that you have in this case. So the question is, why did they wind up adopting us? I mean, there were a couple things. Again, segmentation winds up being very important, and this gets to the point where the service provider has sort of some management applications, and they might be located in their public cloud, they might be in their private cloud, and they might even be local to that particular well site. And the well site, there's hundreds or thousands of well sites. There's N over on the left-hand side, there's a couple private clouds in the middle, and there's a couple public clouds back here, just in terms of scale for a reference point. So segmentation becomes important. End-to-end security. They're now dealing with, this is an oil company is like an end user. These are people like Exxon or Chevron or people like that. They're probably competing with each other. You better not send Exxon, Chevron's data. That's not going to be good for the service provider. And you need to isolate your own data that you're keeping track of here. So end-to-end security. And end-to-end security in this case is going all the way from the edge here back to the public cloud or maybe to here. So it's a variety of different locations that you're going to. It's not just a single point that you might be sending particular data to. Multipath reliability. Again, a well site in the middle of nowhere. One of the original reasons that they came to us, and this was, they might have discussed this earlier, was they tried other SD-WAN solutions across the satellite link and they didn't work well. One of the reasons they didn't work well in this particular case is that that satellite provider that they had WAN opt inside the satellite network, some at the teleport, maybe some in their modem. The problem was as soon as they stuck all the TCP sessions inside a big IPsec tunnel, none of that WAN op could work. It couldn't see the individual TCP sessions, so it couldn't optimize them appropriately. Having a session-based solution in this particular case, you plug in, all of a sudden it works really well, right? Because those TCP, those WAN optimizers could see the individual sessions and act on the individual TCP sessions. Now further, we've also added session optimization, basically our variant of WAN optimization, to the platform as well, so they can actually remove any other WAN op service that they might be paying for in the intermediate nodes. That winds up being very expensive, especially in these satellite networks, so it's a compelling advantage. The bigger picture here, though, is actually multipath reliability, because if you're sitting in a well site and you have LTE, you want to use it instead of using the satellite link, if that's all possible. It's very similar to, you have several ship use cases as well. Same sort of thing. When you're close to shore and can have LTE, take it, absolutely. But you can set policies to be able to either improve reliability or optimize cost. The other one was really an integrated platform. This was actually beneficial to them. This is basically combined boxes, right? Originally, their solution that they were doing at the edge here was essentially a separate network box, a separate IoT gateway, connect them with a cable. Why manage extra boxes here? It's a software solution. You can combine them together. It's very efficient. That's not the primary advantage in this case, but it's definitely a nice bonus. And again, if you're thinking about a software-based solution, it's very easy to do that at the end of the day. So in my mind, this is a very interesting use case. It involves IoT with local sort of edge applications over here. It involves naturally a hybrid or a multi-cloud setting where you have a private cloud, basically required by virtue of the type of private networks they're doing here. You have public cloud that is a preference both for the service provider and then for their customers that will naturally lead to like a proliferation of various clouds. It's unlikely that all their customers are going to choose the same cloud, so it's a very natural type of case. And in the demonstration, and I think Don's covered a little bit of this, he'll show that it's very easy to see that you're operating in several clouds. It's transparent because we abstract that concept altogether. So let me just kind of summarize the types of advantages that we're talking about here. Sort of in that historical hardware-centric model, it was a rack and stack approach in terms of what you do. With the software model, it's great. You can put the same software everywhere. What that does for you is it abstracts and simplifies the network. That's just really desirable as you're deploying in general. When you think about that historical model of dedicated resources, again, each box does its own function. If you start to have shared resources, there's a benefit there. The concern that many people have that shows up in those types of surveys winds up being security. I'm using this shared resource. I don't control all of it. What do I do? Global security policies. That's a great answer. A consistent point of presence in each of these places to be able to control policy, to control the network becomes important. We don't like tunnels. Secure vector routing leads to high performance. We see that in spades in many of the cloud use cases because they're so naturally dependent on IPsec that we can see a lot of benefits there, especially when you start to talk about cost related to it. And then finally, if those services move from the branch to the cloud, reliability is all the more important. And when it moves to multi-cloud, maybe even more so. So that session-centric reliability becomes important. And I think you could see several of these advantages in many of the use cases that we talked about in this particular section, but I think Don's going to emphasize them in a little more detail in terms of the demonstration. But before I pass to him, were there questions on this section? Can I answer any questions related to this? Okay, great.